The purpose of this lab is to find the mass of the black hole. We were given the data for position, time step, and mass of the star orbiting the black hole, and we assumed that it was the only thing exerting force on the star. Using VPython, I created a computational model that used Newton's second law in the form of the momentum principle and the universal law of gravitation to output the mass of the black hole, which ended up being 2.5872 times 10 to the 31st kilograms, and display the path of the star. In previous labs, we were given initial conditions and net force to predict the future of the object's motion. In this lab, however, we are given all the initial data components, the x and y position coordinates, the motion passed, to find the net force, and using this, the mass of the black hole. This lab uses the momentum principle F net equals the change in momentum, which is mass times velocity, divided by the change in time to find the star's initial and final momentum vectors, the change in velocity Vf minus Vi, and the change in momentum Pf minus Pi. After this, we use the momentum principle to find F net and its perpendicular and parallel components. F net is equal to dp over dt, and the direction of dp over dt is p hat, which is the initial momentum over the magnitude of the initial momentum. Therefore, the magnitude of dp over dt is equal to the magnitude of p final minus the magnitude of p initial, all over delta t. The VPython code for this lab is able to take data from a separate file. Then, to initialize the code, I added the given values of the star's mass, the initial position of the black hole, and the delta t. VPython also calculates the change in position over change in time, the change in velocity, over every time step for the x and the y components. The change in momentum can be obtained if this value is multiplied by the mass of the star. The only force acting on the star is the black hole, and because F net equals dp over dt, F net parallel equals dp over dt parallel, and F net perpendicular equals dp over dt perpendicular. The value of dp over dt parallel is the magnitude of dp over dt multiplied by p hat, and since dp over dt equals dp over dt perpendicular plus dp over dt parallel, then we know that dp over dt perpendicular equals dp over dt minus dp over dt parallel. We can use the universal law of gravitation to find the mass of the black hole. We are able to do this because the net force on the star is the gravitational force of the black hole on the star. We can rearrange the universal law of gravitation to be mass of the black hole equals the magnitude of net force divided by r divided by g times the star's mass. I added print blackhole.m to the VPython code to get the mass of the black hole. The initial code was not specific enough, so some more lines had to be edited, and these can be seen here. After the code is edited, we can run it to see the path that the star takes around the black hole. Looking at the image that we get from running the code, we see that there are three arrows. The yellow arrow represents the direction of the net force, and it always points towards the black hole. The black arrow represents F net parallel, and the blue arrow represents F net perpendicular, and it points in the direction that the star curves. In reference to the what does it mean question, the net force is different from dp over dt because net force causes changes in momentum. A force acting on an object in the parallel direction, F net parallel, is going to cause a change in momentum in the parallel direction, dp over dt parallel, such as speeding up or slowing down. A force acting on an object in the perpendicular direction, F net perpendicular, is going to cause a change in the momentum in the perpendicular direction, making the object turn or change direction. In reference to the what-if question, if there were a new black hole with a new mass, the new mass would change the net force on the star. This is because F net equals g times mass times black hole times mass of the star divided by the magnitude of r squared. With a new net force, there would be a new orbit for the star because it will have different parallel and perpendicular momentum. Change in the mass of the black hole would change the gravitational force, and seeing as the only force acting on the star is a gravitational force, the net force of the star would also change, and so the momentum and orbit of the star would change.